Alkaloids. So the word alkaloid, it was coined by German scientist Carl F.W. Missner in 1815. Alkaloids, they are alkali-like, hence the word alkaloid was given to them. Definition of alkaloids. So it is a group of naturally occurring organic compounds which are basic in nature and they contain one or more nitrogen atoms in their heterocyclic ring and they possess specific physiological action. Distribution of alkaloids. So they are found abundant in angiosperms, that is the higher plants. Occurrence of alkaloids. So they occur as the salts of various organic acids like oxalic acid, citric acid, acetic acid, malic acid, lactic acid, fumaric acid, etc. Functions of alkaloids in plants. They act as protective, that is, they act against insects and herbivorous, that is, because of the bitterness and the toxicity they possess. So because they are bitter to taste and they are toxic in nature, so various insects and herbivores, they do not like to eat these plants which have alkaloids. So these alkaloids, they are protective in nature to the plants. Some of these are the product of detoxification also, that is, they are the waste products of the plants and they are reservoir for the protein synthesis in plants and they are also source of nitrogen in case of deficiency in plants. So if the plant it suffers from the deficiency of nitrogen, they can utilize the nitrogen of alkaloids to overcome it. Then coming to the indole alkaloids, so since we have these two drugs in our syllabus, Vinca and Rolfia, and these two drugs, they have indole alkaloids in them. So we will be focusing on the indole alkaloids. So indole, it is 1H indole, it is a benzopyrrole, that is, you have a benzene and pyrrole rings in indole which are fused at second and third position of the pyrrole. The indole nucleus, it is the large number of naturally occurring compounds. So you will find this indole nucleus in large number of naturally occurring compounds. The commercial importance of indole alkaloids or indole nucleus, it is a component of perfumes. So many of the perfumes, they have the indole nucleus in them. They have the compounds which have indole nucleus in them. Then you have isoindole, which is 1H isoindole. So this is the isomer of these two, indole and isoindole. These are the isomer of each other. So here also you will find a benzene and pyrrole rings, but these rings will be fused at position 3rd and 4th of the pyrrole. So this is the 3rd and 4th position of the pyrrole where they will get fused together each, and this makes it unstable. So other few derivatives are also there, the simplest being the N-methyl isoindole. तो इसका एक और आपके पास डेरिवेटिव है जो सिंपलेस्ट फॉर्म है इसकी, that is N-methyl isoindole. So indole, it was first obtained in 1866 by the scientist Adolf von Baer. But the interest of indole alkaloids in indole chemistry, it only began in 1930 because this essential amino acid tryptophan, it has indole ring into it. The plant hormone, that is heteroauxin, it has indole ring into it, and various other several groups of important alkaloids, they were the indole derivative. So the interest in the indole chemistry began in 1930. Indole, it is colorless crystalline solid with melting point of 52 to 54 degrees centigrade, and when it is in form of liquid, then it will have a boiling point of 254 degrees centigrade. The molecule of indole, it is planar and has only moderate polarity. Indole has good solubility in petroleum ether, benzene, chloroform and hot water. The solubility of indole is in cold water, it is only 1:540. That is, 1 part of indole, it is soluble in 540 parts of cold water. So very less solubility is there at 25 degrees centigrade. Water, it is a good solvent for purification by recrystallization. Indole, it forms salts with high concentrations of both strong bases and strong acids. So if you have strong bases or strong acids with high concentration, so this indole, they will form the salts with these strong bases or strong acids. Many indole alkaloids, they include isoprene groups into them also, and so they are called as terpene indole alkaloids, or they are called as sacchaloganin tryptamine alkaloids, because they possess this isoprene group into them. Indole alkaloids, it is the largest class of alkaloids. The amino acid tryptophan, it is the precursor for the indole alkaloids. So this indole alkaloids, they are synthesized in the plants from amino acid tryptophan. So this amino acid tryptophan, it is the precursor for the biosynthesis of indole alkaloids in the plants. So this, it is based on biosynthesis, that is, it is of two types, the isoprenoids and non-isoprenoids. So based on the biosynthesis, you have two types of indole alkaloids, isoprenoid indole alkaloid and non-isoprenoid indole alkaloids. The non-isoprenoids, they are further subclassified into different types. The first one is the simple derivatives of indole, that is biogenic amines, tryptamine and 5-HT, that is 5-hydroxytryptamine, also known as serotonin. Then you have camelexin, which is obtained from the plant Arabidopsis thaliana. So this is the simple derivative of indole. Then you have second type, that is simple derivatives of beta carbolene. You have examples harmine, harmaline, harmane. They were isolated in 1838. Then third is the pyrolyol indole alkaloids. So these are produced by methylation of indole nucleus at the third position and by the nucleophilic addition at carbon atom of the position second and with the closure of ethyl amino group into a ring. So this constitutes a pyrolyol indole alkaloids. For example, physostigmine, it was isolated in 1864. Then you have fourth one, indole 3-carbinol, then you have indole 3-acetic acid, you have tryptamines, you have carbarols. So isoprenoids, they are synthesized from dimethyl allyl pyrophosphate and isopentenyl pyrophosphate. So this we have studied in the first unit also. The isoprenoids, you have example hemiterpenoids. These hemiterpenoids, the example is ergot. Then you have monoterpenoids or sacchaloganin tryptamine alkaloids, and these contain 9 to 10 carbon fragments. For example, ajmelecin, this has C9, that is carbon 9 fragments. Then catharanthine, it has C10 fragments. Vindoline, it has C10 fragments. And this particular, it represents the structure of lysergic acid. So lysergic acid, here the tryptophan fragment, this yellow one, this is the tryptophan fragment, this is in yellow color, whereas this blue color, this is the isoprenoid part from DMAPP, that is dimethyl allyl pyrophosphate, which is in blue color. Then we have bis indole alkaloids. So these are the dimers of strictosylidine with the examples vincristine and vinblastine. So catharanthine, it is the precursor for vinblastine and vindoline. Then you have euhembine, you have example cubarsine, the indole alkaloids, which is derived from the bark of the African tree johembi. You have Vinca, strychnine, which is derived from the Strychnos nux vomica. Then you have ellipticine, derived from Orchosia elliptica and Rolpia sandwichensis. So these are the bis indole alkaloids. So coming to the Vinca alkaloids. So Vinca alkaloids, they were found out in the 1950s by the Canadian scientists Robert Noble and Charles Beer for the first time. These are dimeric alkaloids having indole and dihydroindole nuclei. So Vinca alkaloids, these are the dimeric alkaloids which has indole nucleus into them as well as the dihydroindole nucleus into them. The vincristine and vinblastine, these are the major alkaloids in Vinca. So as we know that these two alkaloids, that is vincristine and vinblastine, these two are the major alkaloids of Vinca plant, and they differs only in the substitution on the nitrogen atom of dihydroindole nucleus. So at the nitrogen atom, there is difference at this particular substitution on the nitrogen atom of this particular nucleus, that is dihydroindole nucleus. Although the name represents alkali-like, some do not exhibit alkaline properties. So although they are alkali-like compounds, but some of them, they do not possess this alkali property. There are 4 major Vinca alkaloids in clinical use. So we have 4 major Vinca alkaloids, that is these two we already know, vincristine and vinblastine. Apart from that, we have vinorelbine and vindecine. So these 4 are the major alkaloids of Vinca which are used clinically. So this Vinca alkaloids, they are classified into 3 types. The first generation Vinca alkaloids which are obtained naturally. We have example vincristine and vinblastine. Then we have second generation Vinca alkaloids. These are semi-synthetic in nature. That is example is vindecine and vinorelbine. Then we have third generation of Vinca alkaloids. These are purely synthetic. We have example vinfluminine. Vinca alkaloids, they have dimeric chemical structure. That is 2 basic multi-ringed units they have. So dimeric means they have 2 multi-ringed units in them. The one is indole nucleus, the another one is dihydroindole nucleus. So this indole nucleus in Vinca alkaloids, it is referred to as catharanthine nucleus, and dihydroindole nucleus, it is referred as vindoline nucleus. And these 2 nuclei, they are joined together with some other complex systems. So these are the 2 structures, that is you have catharanthine nucleus over here and you have vindoline nucleus over here. So this total complete forms the structure of Vinca alkaloids. So these are the R1 group, R2 group, R3 group, R4 group and R5 group. So R4 and R5 group, they are in the catharanthine nucleus, whereas this R1, R2, R3, they are in the vindoline nucleus. So when you replace these particular groups at this R1, R2, R3, R4, R5 position, so you will get vinblastine, vincristine, vindecine, vinorelbine and vinfluminine. So these 2 upper ones, that is vinblastine and vincristine, they are the natural alkaloids, whereas these two are the semi-synthetic alkaloids, and the last one, this is the synthetic alkaloid. So these are the Vinca alkaloids. So this is a basic structure of Vinca alkaloids with the catharanthine nucleus and the vindoline nucleus. So in vindoline nucleus, you have R1, R2,